So this morning, we got our first glimpse of the AnyLogic user interface, and we were able to see how we could use that interface to characterize some basic components of a model. These included depicting agent properties. There are aspects of their state, so we could situate them in a certain environment, and we could give them rules for evolving according to these state charts. But I'd like to go through with you this afternoon on a couple exercises that will get you actually building models from the ground up in AnyLogic, and give you a feel for where that model came from this morning, that toy model.
Where is that found?
Okay, this one?
Yeah.
It's in the lecture slides area on the Dropbox. So I'll see if I can get it for you here. There it is. Okay, so if you go into lecture slides, it's called Specifying Agent Properties, Parameters and Heterogeneity. You got that? Is it, do you see that there? What's that? Okay, that's great. Yeah, so it's in the lecture slide, sure. What I'd like to do is to open up AnyLogic, and we're going to discuss this model, the modeling framework, the modeling environment, a little bit more detail than we were able to do so this morning. Yeah. Oh, okay. So it's somehow not been uploaded? Okay. Yeah, it says it must have been disconnected when the network dropped. So it looks like it's uploading files. Okay. So I was just informed by my TA that it looks like I got disconnected from the network earlier, so it looks like it's still uploading things from my computer. So it will be there in a bit. Okay, so I'd like you to create a new model. If you go into AnyLogic, you should be able to do File, New, Model, and we're going to create a model from scratch. And this model will end up being called. I have a model called Simple Gender Disparities in Income, so you might want to use that name. Or you can just call it heterogeneity would be another aspect. I called it Simple Gender Disparities in Income. Okay, and this is going to be our first model. It's going to be a model which you can find in its whole form on the Dropbox site right now. So when we do that, we're going to get a model created for us with two components as part of it. Number one, a so-called main class, and number two, this experiment. So again, what did I do? I did File, New, Model, and I typed out the name Simple Gender Disparities in Income, and I said Finish, and it created this model for me. Some of you might not see it because you'll be on the palette or the search, but you might have to go over here to Project to actually see it. Okay. So this environment that we're operating in is AnyLogic standard environment for building models. It's based, for those for whom this is a meaningful statement, this is based on a very popular system for doing software development called Eclipse, which is very widely used. And we're going to learn how to manipulate this framework in the course of our modeling. One thing I want to draw your attention to, as Kurt said this morning, some of these windows can be closed, and if you close a window, you can always go to View up here and get it back by selecting it. And similarly, you can get rid of it from the View menu or by clicking on the X by it. So these models these windows are reconfigurable. Most importantly, by double-clicking on a given window here, you can make it a full screen window, and you can just focus in on that. And then by double-clicking it again, you can you can actually make it bring it back to its normal size. That will sometimes be useful. You can also drag these around to reorder them or what have you. You can drag them all around the screen. I'm trying not to do that so that you don't get your windows in strange places, because often they're in very well-defined places. But you could drag this up there or have it fill half the screen or what have you. So it's a configurable environment. And it's an environment that you should recognize. You can change around, but most importantly, sometimes you want to zoom in on a given area by double-clicking here. Okay, so what does this environment give us? Well, it gives us this depiction of the model over here on the left. These are the various components of a model, and larger models will have many, many components there. Those are the pieces that make up the model. The model's behavior transcends any one of those pieces, but those are the various pieces we use to assemble it. We'll come back to those pieces. Second thing is there's this palette that provides the source for new pieces that we can add to our model. This is kind of the potential pieces we could add in. And there's a wide variety of libraries here on the left, dealing with everything from database connectivity to state charts to charts and data collection mechanisms to visual mechanisms, those various geometric shapes there, visual depiction of algorithms, a whole lot of things, as well as some more specialized ones like pedestrian libraries for trains and that sort of stuff. So we're going to be dragging things over time from this palette. And to whence will we drag them? We'll drag them over to this canvas here. So this canvas, you notice it says main on the top of it. That's very important to pay attention to that. This label up here tells you what this is depicting. Why does it say main? Because I double-clicked on this and it created it. I could close that, double-click on this, and it will depict for me the things associated with this main class. Okay, so this is going to be sort of the canvas on which we'll build a given element here. So we're going to have inside main, we're going to have a population living, etc. So we'll come back to that as well. Down here, there's properties. Whatever's selected here, either over in this window or over here, they can be selected in either window, the properties will show. It'll show the characteristics of that thing that's selected. So this will tell you, essentially what various facts about main here. So, for example, what to do when it starts running, or when it ceases operation. What to do specially for that. Simulation will have a different set of properties for it. For example, how fast do you want it to run, whether you want to be able to sort of drag around in there, how big it should be, and all those sorts of things. Okay. So these are properties. Window log will give you some information when things, with certain types of messages, bad things are happening. There's another window called a problems window that will also tell you, particularly when there's difficulties with your model, it will report them in this problems window. And then there's some more specialized windows like this search and this console, which will let you print out things from your model. It'll say like, I've been infected or something like that. Help you figure out what's going on in the model. Okay, so that's a bit of a glimpse of this framework. We'll learn more about it over time. There'll be some windows for figuring out why a model is doing strange things, etc. But that's the basics of this, of sort of the visual layout. We're going to learn to use two major buttons in this. We'll learn more later. One is so-called build the model. This will actually tell it to get ready to run it. And you want to press that a lot. Whenever you modify the model, you're kind of done with a little bit of modification, you press that, and it will tell you if anything looks really inappropriate with the model, if it makes sense to it, or if there's some mistake that's obvious. It doesn't guarantee the model's correct if it works, but it will stop you from making a lot of silly mistakes. Okay, so that's the build, that thing that says 010. Next to that on the right is the button we've seen before. This runs the model. Okay, so what the heck? Let's run this model. Nothing there. Let's let her rip. So right click on it, you run it. There ain't nothing there. Nothing there. There's nothing to show. Not surprisingly, but it's a complete model. We're going to elaborate it in various ways. Okay. Okay. So we have main. What is this? What is this main thing? It's created with the model. Basically, it's going to be. We talk about agent-based models composed of one or more populations. This main is going to be the stage in which those agents strike. That's going to be the sort of the overall overarching component of the model that's going to keep track of the environment for the agents, and it's going to be the sort of container for where the agents will be circulating. Okay. So main will be something we come back to, and sometimes we'll want like statistics on the whole population. Those will be associated with main. Sometimes we'll want charts depicting what the whole population is doing, how many people are obese versus normal weight versus overweight versus underweight, and that will be depicted in main. Sort of these summary things about the environment in which the agents circulate, and the agent populations will live in main. Okay, the agents will be in those populations. Okay, so that's a little bit about main. So let's go add in an agent and a person. We're going to create a type of person called a person. How did I do that? I did file, new, and then I did agent type, and I said I want to create a person. Okay. I could have called it any number of things. I'm going to be depicting people here. We have other models I've given to you that have deer, or they might have doctors, clinicians as the agents. And in general, your model might have several types of agents interacting in interesting ways. You might have doctors, patients, RNs, LPNs, physiotherapists, various type of clinicians or practitioners. In this case, we're just getting the basics of the ropes down, so we're just going to create one type of agent, person. Okay? So we're going to create a person, and we're going to say finish. And it's going to create this thing called person here. Over on the left-hand side. So our model now has this thing called person. What does that represent? Well, person, what we put in person is we're putting in things that describe sort of what personhood means in this model, what it means to be a person, what's personness in our model. So it might be a state chart, and what that's going to say is every person in our model is going to have, they can go between these different states in a certain way. Or maybe there's characteristics like sex, ethnicity, income. And that's going to say every person carries around in our models a sex, an ethnicity, and an income. Now, when we run the model, there's going to be many persons typically. It's just going to be one main, but many persons. Okay, we're going to work towards that. We're going to create a population of these people. But first, let's go and let's give person a property. Let's make it so that they have some visibility to them. Okay. So what I'd like to do is I'd like to go to palette here, and I'd like you to go to the presentation area. So how did I do that? I clicked over to palette, I click on presentation, and it's this little thing here, presentation. You notice each of these is named presentation. And I'd like you to take an oval and drag it in there. So I'm dragging from the palette to the canvas. Okay. Now this is a wee bit large, so I'm going to actually shrink it down, and I can sort of drag this like that, and I'm going to center it here again. Boom, just like that. Okay. So I just dragged in there, and now we're saying, hey, persons in our model, personhood is associated with a circle. Circle marks where that person is. Okay. It's going to be an aspect of their characteristics. Later, we're going to elaborate that circle so it does useful things for us. Right now, it's just going to mark where they are. Okay? So we have people, and they're associated right now with a single property that I have a circle depicting them. Okay? Great. We're going to come back to them, and we're going to add in various things, but that's great. Let's go up to main. So we've been watching person. Now I'm double-clicked on main, and it shows main here. Again, it's very important for me to keep track which one I'm looking at right now. I'm now looking at main. And we want to add a population of people to main. We want to have main contain a population. Okay? So how do we do that? Well, one really easy way to do that is to drag from this thing that says person over to main. You drag over, and it will say person is the default name, and I'm going to call it population. How did I do that? I clicked on this and dragged over to here. Okay, I'm not going to do it twice. But there's this thing called population. Who needs TA help? TAs? Deploy. Okay. Okay. There's a high need is exhibited for TA services. Okay. Okay. You got Professor. Okay. Oh, okay, folks, if you lose main, just double click on it. Okay, folks, so if main, these windows up here are fairly ephemeral. So watch this, I'm going to get rid of main. And now I want to remember the main. So I can double click here and it will come back. See that?
How do you save?
So if I want to save it, I can do it up here, or I can press Control S. We'll save it. And you'll notice, just as a hint, folks, every time I modify the model, let's suppose I move that, notice there's a little star here, a little asterisk. In the States, they sometimes call it a Nathan Hale. And that indicates the model's been modified. And if you do save, Control S, it goes away because it says, hey, things are squared away. Save. Okay? So great questions. Other questions about what I've done? I've just dragged over. Yep.
What did you do, sorry, can you?
Sure. Okay, so do you have the population here?
Main, okay.
Double click main to get it up there. Like if it's not showing, you double click it, and then you can, if you don't have population now, you can click on this and you drag it over to become a population.
Okay, so click on person and
drag it over.
Okay.
Yeah. Okay?
Okay.
So, and then I named it population. I typed in population. Okay? And I typed it immediately, but you could also type it down here in properties once that's selected. Okay, so folks are okay with that? Okay, we're going to blaze our way forward. Okay, so what do we do next? We want to make this a population of agents. So again, I've selected it. I click population of agents. It's not just a single agent, it's a population. And I'm going to leave it to be 100 agents, okay? 100. I clicked here. People okay with that?
Okay.
Okay. I like the feedback. It's good. Keep it in sync here. Okay, population of agents, 100 agents, right? Okay, folks? Okay, again, this shows that we made a modification. Save it. Build the model. You press it up there. It says, ooh, I should have highlighted that. It says build completed successfully down here. That means things are looking copacetic. Things are encouraging. Okay. Let's go run this model now. We actually have a model that has a population in it now. Let's go run it. It's not going to be very exciting.
What is it supposed to do, do you think?
Well, it's just going to depict a population of size 100 who's not doing anything right now. They're just sitting there. Okay, so here we're running it. See, it says a population of size 100, and I'll actually show you that you can go over here and you can drill down to each person. Here's person 0, here's person 1, person 2. But they all look the same right now. We haven't told them they're going to be living in different places. We've just given them an appearance. They all look the same, but they're there. Actually, I can right-click on this and I'll see them. Oh, look at that. They have a circle up there, and there's their circle, but there's not much going on. But we're going to change that quickly. Okay, who needs TA help? Who needs TA help? Okay, so we're cruising. Yeah. Okay.
Come on.
Okay. So the next thing I want to do, folks, is I would like to go and give these people some characteristics. Okay. So we're going to make them different with characteristics. Later we'll make them placed in different places, but I want to give them some characteristics so they'll differ with those characteristics. Okay, so I'd like you to double click on person here. Okay. And we're going to introduce here an income, okay? Let's give each person an income in this model. How am I going to do that? Well, I go over to the palette, and I go up to this General tab. It's the very top one. And I'm going to drag in what's called a parameter. That's going to be a parameter of this person. It's something I set one time. How did I do that? Okay, wait, what did I do? First of all, I made sure that person was showing. I don't want to be putting that in main. I double click here, person comes up, okay? So I'm looking at person, it's labeled here, and then I go over to palette, and I drag from parameter into here, okay? And I gave it a name income. Let me do that again, just for those who weren't following the first time. I drag it in, boom, and I say income. Notice I type it here, or I can type it down here after it's dragged in. It doesn't really matter which. Okay? People okay with that?
Say the general one.
Yeah?
I don't have the general icon on the
Oh, up at the...
analysis. Well, you do?
Okay, in the palette?
Uh-huh. Yeah, in the palette I can see...
A general? Okay.
I can only see analysis.
Okay, so I think, oh yeah, because that's interesting. Okay, so you don't see general here. Okay, could you go click on this guy? No, that's not there. Okay, click on this guy. Okay, you don't see a general. Okay, I'm gonna need Krugerian help with this. So that's an interesting one. I think what you need to do there, Kurt, is you need to go to this, Kurt. Kurt, down at the bottom here, this plus sign at the bottom. You should be able to add general.
Oh, okay.
You see that?
Oh, okay.
That's weird.
Who snatched general away?
Yeah. Okay. Okay. So we've added this income, and we need to give each person an income. Okay. So folks, this is saying personhood here is now defined to include an income. And I'd like to give them sort of a default expression for income. Now, reflecting the fact that income is something which is asymmetric, the income distribution, I'd like to draw from a log normal distribution. And I'm going to have a log normal distribution with log mean 11, log standard deviation of 0. So sigma is 11, excuse me, mu is 11, sigma is 3.5, and the minimum value is 0. So what this is saying is that every person, when they get created, their income is going to be drawn from a distribution with these characteristics. Okay, it's a log normal distribution with mu 11, sigma 3.5, and minimum value 0, which is not really binding in this case. Okay, who needs help? Is anyone feeling beyond help?
Yeah, I gotta get
Okay.
my
Okay.
life together.
Okay, so log normal. So that's in the default value with this income. It's saying if you don't specify anything else, draw it from this distribution. Every person is going to draw from that. Okay. So, ladies and gentlemen, let's run this thing. Okay. So I tell you, when you make these little logical changes, that's kind of a logical unit, a logical nugget, and let's save it. Control S. Let's build it. It looks fine. And finally, let's run it. Okay, so I right-click there, and I'm going to run this. Okay, so now we see this. Nothing looks too different, but let's drill down to the level of the population. We're going to drill down. Okay, here's a person with an income of $9,400. Here's $40,000. Ooh, I skipped up here. But you can use this to go between the different people in the population. Here's someone with a modest income. Here's someone with a somewhat higher income. Do you see that? Okay, you don't see that?
My
Okay.
neighbor's rich.
Well, okay. Okay. So if you click on this, nope, that, and you click there, and then you can use those to click. Okay, so that's 20,000. Okay. So folks, how did I get to this? How did I get to that? Have some of you hit the jackpot or something?
What about red?
Okay, so here, folks, this is initially what you'll see, and you pull this down to see the individual members of the population. Okay? We're going between members of the population? People okay with that? Okay. Okay. That's good. Okay, so what I'd like you to do now is we're going to go and go back to person, and we're going to go and actually add a different characteristic, okay? The sex characteristic, okay? We're going to give everyone a sex as well, okay? So how are we going to do that? Well, to do this, you can do this in various ways. How might you encode sex in a SAS data set, for example? 0 and 1, right? And we could certainly do that. I'm going to say that's not the preferred way to do it here. You can do it. It's very easy to do, and actually would spare a step here. The reason that it's not the preferred way to do it is because, you know, we might have an encoding of sexes and an encoding of the state of residence, and that might be encoded as 0, 1, 2, 3, up to 49, right? Mm-hmm. And then if you see a 0 circulating, does it mean, you know, male, or does it mean they live in Hawaii, or you know, what does it mean? So it's actually a bit nicer if you can actually give it a clear name, like say male, female.
Oh, okay.
Okay, so we could do it with 0 and 1. We could also do it with true or false. You know, is female, and it would be true for women and false for men. But I'm going to do it in another way. I'm going to go to add a new thing, and it's going to be called an option list. How did I do that? I went up to the whole model. I do new option list, and I'm going to call this sex. Okay. And then I can specify the elements of this, and I'm going to make one male, and I'm going to make one female here. Okay? Okay? Male and female. Okay. So now we're going to be able to indicate for each person there in the population, are they male or female? And let's go do that. So folks, we're going to go to the palette. And to our definition of personhood, again, make sure it's person you're putting this into, we're going to add a parameter called sex, okay? Called sex. Okay.
Sex undefined.
Well, so, in any case, moving right along, its type will be, so we have to associate this with a type. The type for income was a double precision value. We have to associate with sort of some thing indicating what it is. This is going to be a sex. Each person is going to have a sex, and what are the choices? They're going to be defined by this thing, capital S sex, which is, we just defined here. That was that option list we defined. Okay. So each person's sex is going to be given as a member of that sex thing there. So they're either going to be male or female. Okay? And at first, we're going to just make them male. We'll just say that they'll be male. Or you can choose female. We'll just make sure the model works, and then we'll actually have it randomly pick. And there's multiple ways we could do that. Okay, so we're going to go run the model and just make sure it works. Okay, so here we are. How do I get to the population? How do I get to view each member of the population? Someone tell me?
Pull that root.
Pull down that root thing. Yeah, that's right. Okay, you pull that down, and here we have a male with an income. Okay, income, wow. But they're all male right now. Why are they all male? Because I told them to all be male. Okay, so we've got to let there be some coin flips here. Okay? Man, I'm taking you through things pretty fast here. Okay, so let's go back to their sex characteristic, and we're going to actually have that be determined randomly. There's many ways we could do this. If this were states, there's a really crisp way I could do it, but I'm going to show you one way it could be done, which will be of help later in the course. And so I'm going to give you an expression that will allow you to flip a coin, and if it's with probability 0.5, it'll be true, probability 0.5 will be false, and we'll pick either male or female based on that. Okay? So let's do that. This thing will be called random true, and with a probability of 0.5, it will be true. Okay? If random probability 0.5, it will be false. This is calling off a function, saying, hey, give me a thing with 50% probability is true, 50% probability of false. Okay.
Are these Java functions?
This is.
Or they're custom functions?
They're Java functions. These happen to be defined by the AnyLogic libraries, but you can call other Java libraries very easily.
Okay.
Yeah.
But these are Java libraries that are provided by AnyLogic
That's right.
specifically.
That's right. You can add references to external Java libraries, and there's some models that circulate which do that. Yeah. So random true.
And is there a list of these?
There most certainly is. Yeah. And I'll show you. In fact, thank you very much. Your name?
Ben.
Ben. So Ben's question here. Let's suppose we forgot this name. We knew it had something to do with random, right? How would we find out what the possible choices are for this? Well, you can start typing it and press Control Space. This key press is your friend. Okay. So you start typing, you press space, and it will give you a list here. You could be looking to type random, or you could be looking to type random true, or you could be looking to type random point of space, or any number of different things. In this case, it's random true that we want, okay? So that's going to be very helpful, because sometimes you don't remember quite the name. This is going to be random true of 0.5. But then there's a whole reference library associated, it's so-called API description that describes all these functions. And in fact, for this guy, if we had wanted to, we could look under it, and there's this documentation here, etc. Okay, so random true, 0.5. And now I'm going to introduce a little bit of what we call syntax, a little bit of kind of notation. So with this, if this is true, then we'll make it a female, otherwise we'll make it a male. So this is kind of saying, if this is true, make it this, otherwise make it that. So there's a question mark, okay? For those in the back, what I'm going to do is I'm going to make this in a big notepad. So this is what it looks like. Can people see that? Okay. So this is just a bit of thing, and the reason I'm introducing this because it'll be something you will see later in the week, and so I want you to understand how this is done. Again, if these were states or some large list of provinces, we wouldn't do it this way. We'd instead say, pick me a random one from within this using a certain other syntax. But this is a little bit conceptually easier.
Can you repeat the interpretation of that again? The space? Sorry.
Sure. There's spaces, but the spaces don't matter, actually. It doesn't pay attention to spaces. So the interpretation is, we're going to flip a coin with probability 0.5. It's going to be true. If I made that 0.9, it will be 90% of the time it will be true. Here it's 50% of the time it will be true. So flip a coin, and if it's heads, in other words, it's true, it'll be female, otherwise it will be male. So this question mark just means, based on this thing to its left, and these two choices are the two possible outcomes. Female, if that thing returned true up there. Male, if that thing returned false. Does that make sense?
Yeah.
Okay. Questions? Other questions? This is
I don't know Java. Is the standard
Standard.
syntax?
Yeah. It's
if statement, but you can boil it down to a single line.
yeah. This is what's called an expression. It's computing a value. This is like a formula. You could think of it like a formula in Excel.
Yeah.
It's there's an if else type or if formula in Excel. This is the same thing as that, basically. Okay. So this is one of the points we're being stretched today. I know that, and I appreciate your tolerance. It's good that there's no stampede there, and it's not just because Winchell's blocking the door. Okay, so great. So folks, now we have sex determined randomly. We have income determined randomly from a call from distribution. Ladies and gentlemen, let us compute. Let us save the model, build it, make sure it's happy. I built it by going up here. I'm trying to teach you life skills here with this building. If you're using AnyLogic, that's one of the key keys. You want to press it often, press it early. Okay? And then we're going to run this. And we drill down. Okay, so here's a female with a modest income, another one. Okay.
I see.
Male, female, male, male, female. You can see different ones are male, different ones are female. Okay, TAs? TA deployment. Okay. Okay, who needs help? Additional help? Okay, help.
Why am I not in this?
Oh, okay. So did you? Okay, go to sec here.
I want you
Yeah.
to.
Okay. Capitalize. Do this one. Do the second one. Yeah. In this, if you just filled in female for this one, you'd be probably okay. But you probably want to delete the first one too. Yeah. Okay, folks. One thing that someone discovered. Java is case sensitive. So actually, if you typed female in all capitals, it wouldn't know that's the same as female with just the first letter capitalized. So you got to be careful about capitalizing the same way. Specifically, we defined it here to be spelled this way, and therefore, in this expression, we need it to be the same way. Does that make sense? Okay. So, folks, here we have sex and income as dictated randomly in this population. Now we could have sex. Well, I think I'll come back to that later. We'll actually add some richness before that. Okay, so we have sex and income determined randomly. Let's now give people a distinct appearance. Okay, so let's make the situation here such that the width of this circle depends on their income, and we'll make its color depend on their sex. Okay, so we're going to here put the radius of this circle to depend on income. Okay, so we'll make the radius of this circle. So how did we do this? We called up person.
Yes.
And we want to change something. It's a property of the circle about the person. So what do we have to do? We have to go look at the properties of circle. A lot of the art of AnyLogic is actually learning where to go for things. And in this case, we're changing a property, changing a feature, changing a characteristic of the circle, the presentation. So we go there, and if you scroll down, what you'll find is that there's a radius thing here. Okay. And right now it just says radius 15. We're going to click. You'll notice that this equal sign is there. I'm going to click to make it a dynamic value. And we're going to make its radius depend on a formula. A formula involving income. So people with big incomes will be larger. People with small incomes will be smaller. Okay? Okay. So what we're going to make it is, we're going to make it based on the log of their income, and we'll make it based on the log of their income by itself. We could make it times 2, might be a little bit nicer, but let's make it log of their income for now. So the radius here, how did I enter that? I did it by pressing this sort of equal sign. That was for if it's a constant. If it's going to be calculated, you do it with this one. You press that once, and it lets you type this in. Log income. Is that okay? Okay, who needs TA help? Okay, so I did log of income. Okay, ladies and gentlemen, what do I do early? What do I do often?
Say.
Good. That's
And then you
good start. And then I do build, and it's fun. Build basically makes sense. Basically says, hey, does this model make sense to you? Do you know what this means, AnyLogic? It so-called checks the syntax of it and some of the semantics, but it doesn't mean it's right. And then let's run it. Okay, so we see something going on in the upper left-hand corner. How do I go to see the individual members of the population? I go to root, okay. So here we have a female with a small income, here we have a female, male, and you'll notice for each of them what's changing in the upper left.
The circle.
The circle is changing. The circle width. And if we drag it here, we could right click on it, and you go between them, you'll see some of them are bigger, some are smaller. But
How did you drag it?
I do with right click. You right click on that, right click and hold down the right click. See that? So you hold down the right click, yeah. Like this? Is it doing it? Yeah, there you go. So, and then you could scroll up to see different ones here. But this is not really that interesting. I mean, they're all stacked to top of each other. Let's give them a different position now. So I don't want to lose it. Well, first let's have their colors depend on their sex. What color should we make men?
Gray.
Okay, I'll go with, I hear gray. Okay, what color should we make women? Yellow?
Yeah.
Okay. Okay, gray and yellow it is. Okay, so let's go again. Where would I do that? Where would I go to set the color of a person?
Click on.
Okay, appearance of what? Of the circle. Of the circle. Okay, so we have this circle, and we're going to go there, and you see there's this thing called fill color? And we need to make it a dynamic value, not a fixed value, not a static value, a dynamic value. So I clicked on this equal sign again, and we're going to make its fill color depend on their sex. So, ladies and gentlemen, now I want to have something that if they have a male sex, they'll be gray. If they have a female sex, they'll be yellow. How am I going to do that? What sort of expression to say, if this thing is true, give this one, otherwise give that one? Where have we seen that before? Yeah, with the question mark operator, the ternary operator. Okay, so I'm going to say if sex equals male, this equals is, it's something you just got to know. If we're testing equality, you use equals. If you're assigning something, you're saying, make yourself this value, then you'd use equal sign, single equal sign. Okay, sex equals male, then we'll make it gray, otherwise we will make it yellow. Okay? Does that make sense to people?
Does it have to count all caps?
Yeah.
I think they could be either caps, this is one of these cases where they're defined as both, so you could be all lowercase or all uppercase. But
Like the other was just like a shortcut, like you could have said or if sex equals.
Yes.
Yeah.
yeah, you could do that. So if this is true, you use this one, otherwise do that one. But yeah, we could have had a separate check. Yep. Okay? People okay with that? Who needs TA help? They stand ready to serve you. Okay? Okay, what do we do early? What do we do often?
Save and then you build
Save, build,
and run it.
and then run it. Are you folks getting sick of me already? Or?
No, we need that.
Okay, now what do we see in the upper left? Well, we see some hints of color. Okay, here's a male who's gray. Here's a male who's gray. Here's a female, and the size of it, the size is given by their income. Okay, so that's pretty nifty. Who needs TA help? Okay, okay, but they're all crowded in the upper left corner. Their position isn't varying at all, which is somewhat disconcerting. So what I'd like to do is I'd like to lay them out randomly, okay? I'd like to lay them out so that they are spread out at different places in the population. Ladies and gentlemen, those people live in this population in Maine. They live there, and actually it's Maine is responsible by default for setting their location. You can have them each set their own location in their own special way, but if you have a general sort of rule, you'd go up to Maine And if we go up to Main and we go to the properties on Main, so we're looking at Main down here, and you scroll down, there's this thing here that says layout type. See that? See it says layout type? Where do I see it? Where do I did it? I went to projects, clicked on Main, scroll all the way down here until you see this thing, environment for other agents, and it's a layout type, and you'd make it random. Okay, so who needs TA help for this? Okay, there's a TA help back there. So what did I do here again? I went over here to project, went to Main, I scrolled down here looking for this place where it's mentioning this sort of stuff, and I changed its layout type to random. Okay, do you see that? By the way, this is also described in those exercises that are on there, so you can follow those if you want to rehearse this later. But we're going to rehearse it like a Bach fugue, like an Escher drum. We're gonna iterate. We're gonna recurse and come back to these points. Okay, so layout type here is given as random, and it's in the main properties. Okay, so what that's saying is for all the agents within me, make them randomly laid out. We can specify a bunch of layouts, and each agent could take charge of its own layout, but this is the easiest way to do it in this case. Okay, so let's, ladies and gentlemen, let us save, let us build, it's happy, and let us finally run. There we go. What do we see before us? What lies before you? Okay. Yes, so there's a population, and each person in the population is depicted at a random location. If we were to drill down, we would see these variations here, but each of those is a person within this population here. Okay? They're scattered around. Some are bigger than others because they're wealthier, and some are gray because they're male, right? Okay? So here we have a population depicted visually.
But I'm just saying, this is interesting.
Yeah.
But what happens when they get clicky and they get Beverly Hillsy versus
Okay.
the cluster?
So this is a good question, and I have one of the models that I provided to you actually illustrates that. Do you want to do that?
No, we'll wait.
We could.
Because I don't want to take.
We could actually do that very readily. If you want to make their location depend on their income, for example, so that there's sort of an income gradient in space. Yeah, we could do that. Let me just rehearse here. Exactly what we would do. I think this could be done quite readily here. Right. Okay, sure. Excellent. Okay, so let's do that. I like your suggestion. Let's give them an income gradient to their location. So their spatial location will be determined by their income. Okay? Their X location will be determined by their income. So we'll have Beverly Hills to Watts, right? This sort of transition. Good. Let's impose that. So in order to do that, we would relax this a bit. So let's go up to main, and we're going to go to actually this population of agents, okay? And if you click on the population, we could click on the population here, or we could click on it over here. You can do either one. And then you have to go down to initial location, the initial location for the person in that population. And you notice it says place agents at the agent animation location, or in the specified point. And let's make their X location given by their income. Okay? Their X location in space will be given by their income. Now, that's a pretty broad set of incomes. So let's make it by the log of their income. The log of their income times 10, okay? Because the income varies some are hundreds of thousands, and they'll be way off there otherwise. So I'm going to make a log of their income. It's a log normal distribution, and I think it would be much more effective to look at it this way. And then their y location, let's have that be determined randomly. Okay? Sure. Their y location. So, ladies and gentlemen, when we needed to draw a value from a random number from a log normal distribution, what did we do? Remember that earlier? We set their income to depend on a log normal distribution. What did we do?
Who did that?
We called log normal, right? Yeah, right here. So if we want to have their y position be dependent on a uniform distribution, what do you think we'd call? Uniform. And in this case, it'll be between 0 and 500. 500 being the height of the space. I know that, and there's a way you could go get that value automatically, but to simplify things, I'll just put 500 there. Okay. Wow. We just done something pretty interesting. Thanks to your name?
Lisa.
Lisa's question. Okay. So here we've set the x location be determined by their income, the y location by drawn from a uniform distribution. We save, we build, and it says, oh, income cannot be, okay, fine. We have to obey this little thing, which I had not noticed. We actually have to say, okay, this will be your first encounter with, you need to say, okay, whose income? Their own income. The income of themselves. You have to say self.income here. And it tells you that over here with this little light bulb. It says use self to refer to them. Okay? Okay. So it's self.income.
That means you could make your positions dependent on someone else's income too.
Yeah, that's true. Yeah. Okay, so let's try building this now. Okay, happy. Oh, look at that. Oh man. Okay, that is that actually accurate? Okay. That does not look sorted by that. Okay, now why is that? Because I would think their income at that point would be set. Oh, I forgot, of course. It says these settings are only applied if the user-defined layout type. So we actually have to go here, and it actually says, okay, user-defined. We have to have the layout, instead of being random, be user-defined. There we go. Okay. So it's under properties and of main, environment for agents, layout type, user-defined. Okay. So let's go see. Okay. If this is going to there we go.
Ooh.
There's your Beverly Hills, and there's your downtown core, Vancouver's east side. So here we have this income gradient. Now it doesn't look terribly nice. Suppose we want to spread it out some. What would we do? Based on what we've just seen, what would we do to spread it out? What do we need to do to spread it out? Sorry? Okay. Where do we dictate where their X location was going to be? Anyone remember?
Environment?
Yeah, it was in associated with the population, this thing right here. We made it times 10, let's make it times 50. And let's spread them out more. So here we go. There you go, it's spread out even more, okay? So here are the very lowest income people, here are the medium, here are the high income people, very few of them, spread out in their private enclaves in the Lomas of Beverly Hills. Okay? So that was in response to Lisa's question. Let's rehearse what we did here. the very first thing we did, ladies and gentlemen, was we associated with each person with an income and with a sex. For that income, how did we do that? We dragged in these so-called parameters from over here, and we had the income be drawn by default from a log normal distribution. For sex, we actually went and defined so there could be a set of sexes that are possible, and then we drew the sex from either male or female with a coin flip. Now, we initially then set the appearance, their appearance as given by this, to depend on their sex according to color, and to depend on their income according to radius. And finally, we went and we set their location. Their location was initially set down here as being randomly distributed, and then we got a question, well, what if we wanted to capture propinquity? The fact you tend to live near people like you. Live physically, like geographically near. And I went and I said, oh, I thought we could do that. And I went to the population, and I said, okay, locate them not at some way fixed by the environment like random layout. Do it at the specified point, and then to complete that, I went back up here and I said that we needed to, for all of Maine, we needed to set their layout type to be user defined, and that allowed that to happen. And then finally, I fine-tuned it to make this 50 instead of 10. And that, ladies and gentlemen, led to this patterning. Now, in my example, I provided a further example about how you could make incomes depend on sex, if you wanted to. So you could have a different distribution for men and for women, for example, for income, reflecting the gender disparities we see in income even for the first type of work. If you wanted to capture that in your model, I show in my little example model how we could do it. And it's quite simple, ladies and gentlemen. It's a matter of going and setting it so that that here, now you'd have income depend on the value of sex. So people's income would be one log normal distribution if they were male, another log normal distribution if they were female, much as their appearance could be one color if they were male, one color if they were female. Just like this sort of thing. We built up our first model. We've laid it out. We've seen some principles here. We've seen this principle of building. If you make a mistake, AnyLogic will tell you. Let me deliberately make a mistake. Let's suppose I misspelled gray. Let's suppose I spelled it like this, right? And I misspelled it. It will say cannot be resolved. I build, and it will give in this problems window. And if I clicked on this, it will actually bring me to that point where the problem is. Ladies and gentlemen, you want to press build frequently so that it doesn't have a huge number of things here. Just a small number, you can figure out what's going on more easily. So if something comes up here, you double click on it, it will bring you to the point typically, and you can go correct it. So that's one thing, is it will point out some obvious problems. It doesn't guarantee your model's right if it doesn't complain. If it doesn't complain, it just means it thinks it knows what you want to do. That may not be what you actually want to do. It will do what you've told it to do precisely, not necessarily what you want it to do. You have to be careful about that. Another principle we learned is that it's case sensitive. If I did this, it wouldn't recognize it. It will be an unhappy camper because it's not the same as this. So it's actually case sensitive. You got to be careful with your case. Another principle we learned is that we are doing programming here in a way, folks, but a lot of it's what we call declarative programming. We're specifying what we want and less so the how. In other words, we're specifying what color we want by specifying this little formula, sort of like you do in Excel. You specify a formula for something. And it, just like Excel takes care of calculating all the cells in the right way, this takes care of making that happen. Takes care of the how that happens. So you say, I want the fill color to be given by this, and it will take care of it. You say, I want the radius to be given by this, it will take care of it. Income could be changing over time. It will make sure it gets enlarged and shrunk accordingly over time. Okay? So a lot of the programming in AnyLogic, not all, but a lot of it gets done in these sort of formulas. Much like in Excel, you insert those formulas to say this cell is that cell plus this other one or what have you. Okay, so here's fill color, radius. We saw that we have to specify that for the circle because there are properties of the circle within each person. So we have to have it depend on the fill color, okay? Or the fill color depend on this thing, on the person's sex. We make the radius depend on their income. Anyway, and we saw how main sort of kept track of all these agents. So we've given agents heterogeneity. We've laid them out according to that heterogeneity. We've changed their visual characteristics according to that heterogeneity. And you built, ladies and gentlemen, your first model in AnyLogic. Okay? Any questions on that before we go on to another topic? Yes?
Is there a heuristic for understanding where different formulas go? So, for
Yeah.
example, in the income,
Yeah.
income's determined in the population
Yeah.
button, but I, for example, would have thought it would be on the person button. So, is there a good way to?
Yeah, it's a great question, and in fact, your intuition is bang on in the fact that, like, actually you specify a default value here. There are a few simple rules which I could write down for you about where things live, sort of rules of thumb. I'd say that of all the challenges AnyLogic presents, this is one of the bigger ones. It's not a showstopper in the sense that you can typically find it after a bit of futzing, but for beginners particularly, it's often easy to forget. Is that specified in the agent or is it specified in the population? It's easy to forget that sort of thing. In the agent takes care of most of the assumptions about it. But for a population, AnyLogic tries to make it easy for you to say, well, this population is a high SES population, this population is a low one. So it lets you kind of specify different values for the population that are specified by default for the person. So the person specifies here, like the income for the person will specify a default rule to be used for this. And you actually don't have to give that, but generally you do. But for each population, it lets you further. So as a general rule, parameters are specified by whatever is responsible for creating the thing in which they're located. If it's in a person, main is responsible for creating it, and particularly the population, and therefore it'll specify the rules for this. If you have a parameter, let's go do that. This will help show the principle, okay? So folks, for a person, we have shown parameters here and who specified them, who gave the values for them. In general, it's the thing that creates them in the population. They live in this population, they're created by the population, therefore the values are specified by the population. The same principle, ladies and gentlemen, is true at the main level. Okay, so let's go create a parameter for main. Parameters, like state charts, aren't limited to certain subparts of the model. We often see state charts at the individual level. We could put them in main if we wanted to. Here, let's put a parameter in main. This is very common. So what sort of parameter would live in main? What sort of parameter would be like a parameter about the whole model? Well, like the population size. What's the size of the population? That's something about the whole model. It's not something about a particular person, right? Okay, so let's go up, double-click on main. Double-click on main here, and let's go to the palette, and then let's drag over a parameter into main and call it population size. Okay? People comfortable with that? Okay. And now let's have the population size actually depend on this parameter called population size. How would we do that? What would be responsible for? Generally speaking, as a rule of thumb, the components of the model are responsible for their own behavior, their own sort of characteristics. Generally, we look to those pieces to specify these things. So one exception really is these parameters is sort of a notable exception to that. here, where would we specify the population size? Who remembers where that was specified?
Main agents population.
Okay, yeah, it was in this population. It says initial number of agents. So we're going to change that to be population size. Okay, so now it's not going to be 100. It's going to be whatever the value of the population size is. Okay? People okay with that? So we clicked on population here, and we're going to make its initial number of agents be given not by 100, but by population size. Okay? Does that make sense? Okay. Now this population size, we want to give it some default value in case we forget to specify. And we also want to make it an int. It's not a double. It's not like 253.2564 agents. Instead, it's going to be an integer. It's going to be 0, 1, 2, minus, well, not minus 1, but 63. And we're going to make it an integer, and its default value is 100. 100, okay? But now we're going to be able to change that. We're going to be able to change it. Now, the principle I want to commit, your name? Gil. So to address Gil's question, who's responsible for setting the population size? I told the principle here is that whoever creates the thing is responsible for setting parameter values. Persons were created by their population, so that was in general responsible for setting the values. Who creates main? Who tells main, hey, come into existence with these assumptions? We saw it this morning. How did we create a longer duration infection? We created a new experiment. It's the experiment that tells main, that brings main into existence. It's the experiment that tells main what to assume, and it's the experiment that runs main and sees that it finishes and disappears. So here, ladies and gentlemen, we have an experiment called simulation, and notice in the parameters value we can make assumptions about population size. Ladies and gentlemen, let's create a new experiment. We do go up to the model, new experiment, and let's create one that says big, big population. Okay? And being from Saskatchewan, let's make that 1,000. 1,000 people, which is a sizable urban center in our north. 1,000 people here. Okay, big population. Let's run this now. What do we expect to see? It's almost like LA.
A big population, so
Yeah.
what's the size?
1,000. Okay, so there's our population. And there you can really see the Beverly Hills effect. Right? I mean, if you want to push it, do 10,000. If you want to make it a really big population, okay, there we go. We ain't in Saskatchewan anymore. So, okay, who needs TA help? So here, what I'm trying to say to Gil is that for a parameter, whoever creates the thing is responsible for setting the parameter values. An experiment creates an instance of main. It brings it into existence. So it's responsible for setting the parameter value. And that's why we have, for the experiment, we could set the population size. This experiment has a population size of 10,000. This experiment of 100. Who creates a person is a population, and it's a population, therefore, which specifies the assumptions to use for those people within it, like what their income distribution is or whatever. Does that make sense? Okay. So we've seen that parameters can be used at any different number of levels, at the level of main, at the level of a person, at the level of, if you had a school is an agent, that could be represented, or what have you, a city. That could be represented. It would have its own parameters, and whatever created it would be responsible for specifying. Okay, good questions. Other questions before I close this lecture? And we'll go to another lecture. Questions? Yeah.
Just a quick follow-up. So do we want to think of it as a hierarchy with experiment
Yeah.
at high level and main and person?
To a degree. The experiment brings main into existence. It's not really... it's not really structurally around Maine, but people do live in Maine. They live in these populations within Maine, so that's useful. They're kind of nested in Maine. I wouldn't think of Maine as nested in the experiment, except the experiment sort of brings it into existence, lets it run through it, and finishes it, but it's not really enveloping it completely. It just sort of is responsible for managing it. I don't know if that's helpful, but that's kind of the way I would think of it. It's not really structurally around it. But you can create other nested contexts, and later we may see, a person in a school, in a neighborhood, in a city, in which case there'd be a nesting relationship, and that's captured in the model. But I wouldn't really say that Maine lives inside an experiment. It's just the experiment brings it into existence and basically shepherds it through its existence and finishes it at the end. And this will be very important in a later lecture, okay? Because it may run Maine many times, like in a sensitivity analysis, or run it many, many, many times to get summary results across many instances of Maine. So this will become very important. Right now, we kind of have Maine, it's just running Maine once, but in general, it can run it many times. Okay? Okay, other questions? Great questions. Okay, so we're gonna finish that. If people want to do a quick bathroom break, I'll just switch over to my next lecture. Maybe you could come back in about 5 minutes.
Are you ready?